Hi everybody, it's Mr. Bennett here again. We're going to today to look at the volume of shape. This is question number 10 out of your textbook. Pretty well two types of shapes. If we look at the shape here, the concrete that we call prisms, and those that are internal diameter of prisms. So the first lot of shape here, a wall thickness of 30 centimeters. Basically, it doesn't matter what the bottom tank over here. We could say just have that same shape going all the way through then. The volume of that shape is in the area of the shaded bit as the end bit times by the length. Diameter is 6 metres. And if we start looking at over here, pyramids, we've got a radius. They go to a point, so it's simply going to be a third area of the base times by the height. To work out the volume, the other shape that you will see is going to be a sphere, which is 4/3 pi r cubed. We'll label the dimensions of that. I'll just scroll down a bit further. I've got something take away the smaller cylinder because you imagine if that was filled up. Again, the three shapes that you will know. Area of triangles half base times height. We now also could use Herod's formula or half AB sine C is going to be 5 metres, simply times that by the height. And the radius of the height of this pyramid over here is for a pyramid is simply a third of that area times by the height. For a rectangle, it's going to be 3 metres length times width. And again, we times it by the height. So if we look at the smaller tank, the volume of that inside, and then we go to look at the area of the circle, it's pi r squared, and the perimeter is only going to have a radius of. And again, same concept is for the prism. And this tank here, the height of its height be only pyramid we go 32 of the base times by its 7 metres. Now, you probably don't know this, but you can certainly remember the volume of a cylinder. It's going to be simply, and then we go to here, it's pi r squared times by the height. There's some information about if I substitute straight in units for you there. Obviously, it's going to be pi times by the radius for how big the ounce squared, being 1,000, by the height being 3. And then we get into looking at how the other one, which is going to be square metres to cubic metres. Alright, so we'll talk about that squared times by the height. Which example out of your textbook is question 8, ice cream cone. So if we're thinking, if we go to our calculator and do that calculation, we need to consider the two shapes that we do have here. Simply going to be the volume of that shape is going to be simply the hemisphere times by 3. Taking at the particular shape there, hemisphere, that's got a radius. That's going to be 4.72 centimetres. And then we've got a cone times by. Now we need to consider the cone has a thickness. And that should give us the cone is in fact 8.2 millimetres. So if we know that radius there, then the radius to our particular edge of the thing is going to be 1.4825 centimetres. Because it's got a 2 millimetre thickness. So if we write down our formulas for those, then that's going to be a half of, because we're working 4/3. Anyway, thank you for listening. I hope that helped. And if you've got any questions about that, and this one here is please be simply a third. Bye for now. Thanks for being a pyramid. See ya. The area of the base, which is pi r squared times by the height. It's probably it is good to actually write down the formulas you're using as a first part of your problem solving. The next thing I could do is I could simplify this a bit here. I could cancel the 2 out there with that and leave that with there. So that will give me 2/3 pi times by the radius cubed. So the radius there is 2 cubed plus a third of the other bit, which is pi times by the radius. Now the radius of this is 1.8 squared times by the height, which is 6 centimetres. Right, so that's in centimetres. So when we get our answer, the answer will be in centimetres cubed, all right, which is the same as millimetres. So if we go to our calculator and put that into our calculator, so it's going to be 2 divided by 3 times by pi times by our radius, which is going to be then cubed. So we're using that for our cube button. And then we go across and we add 1/3, 1 divided by 3 times by pi times by our radius, which is 1.8. We're going to square that, and then we're going to times that by 6. We go enter, and that will give us an answer of 37.11, and that will be in cubic centimetres. So that will then be 37.11 cubic centimetres, which is in fact equal to 37.11 millilitres. Now what we're assuming here is that the cone is going to be uniform and the fact that the ice cream is going to fill the whole cone. In reality, most times it's just a big sphere that they put in there, so there will be a gap with that. Anyway, thank you for listening. If you have any questions, make sure you catch up with me in class and I will talk to you later. Bye for now.